Okay, this is session 2, application and design. Everything we're going to talk about today is in all of the installation and service literature, mainly the installation literature today. We're going to talk in generalities. You should always follow it up with looking at the install manual to verify. Because things like torque is maybe different on one unit versus another, or piping specifications on one versus another. But talk about how to find the information and general rules of thumb per se today. But all of the information is in the installation guide that comes with the equipment. All the equipment comes with is an installation guide. All the service literature and submittals, any other type of the literature, you have to go to mylinkdrive.com to get that information. Okay, some of the common installation problems we find is incorrect wiring. We'll talk today about the wiring sizes and the way we wire it, but typically on the one-to-one units, the one outdoor unit and one indoor unit, we run 4 wires, 3 wires with the ground, and the terminals are S1, S2, and S3, and they have to be in that order. So S1 on the outdoor unit goes to S1 on the indoor unit, and so on and so forth. Because the power is on S1 and 2, and the communication is between S2 and S3. And if you mix them up and you put line voltage to S3, we could have some issues. So incorrect wiring is one of the things. We always use the wire directly from the outdoor directly to the indoor with no wire nuts, as seen here, and no switches in there like this. If you have to put a disconnect switch in, there is an approved Mitsubishi disconnect switch. It's a 3-pole single throw 3-pole switch that will disconnect the indoor equipment if it's required by local codes. Typically it's not. Everything goes through the outdoor unit. When you kill the outdoor unit, everything that's connected to it is shut off. And if you're using a multi-zone unit, if you do use switches, you have to power them up in a certain sequence. Refrigerant piping should be insulated properly, hopefully no gaps like this. We insulate both the, I guess you'd call high and low side, or what would traditionally be called the liquid line and suction line. Our liquid line is not a true liquid line, it's a saturated vapor line. Our expansion valves, or LEVs, linear expansion valves, or electronic expansion valves, some people call them, are typically in the outdoor unit, not in the air handler by the evaporator. So the liquid line then becomes a saturated vapor line, and it does cool off below the dew point and will sweat in the summer. So you definitely want to insulate it, and in the winter that becomes your liquid line, basically right off the discharge side of the compressor right into the coil inside, so you don't want to lose any heat on that in the winter to make it inefficient. So you want to insulate the pipes properly, have good flares. We'll talk a bit about flaring today. You can see here from the oil that there was a leak. I always look for oil when I'm looking for leaks. But you want to get a good flaring tool and make a good flare, and we'll talk about that a little later. Also, condensate is an issue, so we'll talk about that and how to run the unit actually downhill. Obviously, you want to run water downhill like a drain downhill, but you can't have any traps in it. So if you're using a vinyl tubing, you can't have dips in the vinyl tubing. And in this case, this is running out onto a roof, so this could create some sort of mold or mildew or staining of the roof. So you want to run that down all the way down to the ground if you're running it outside. And your refrigerant lines here, you don't want to run a loop on the refrigerant line because that creates a trap. You want to try to run it all downhill so you don't trap the lines. Also here, this braze here was done with nitrogen. If you are going to braze, typically we use flared fittings, but if you are going to braze, definitely use nitrogen to avoid this black oxidation inside the pipe. The black oxidation is a bunch of black flecks that will wash off when you start the refrigerant system up. The refrigerant and R410 and the refrigerant oils will clean all that stuff off and move it throughout the system. But our system has 100 mesh screens throughout, and it has, and we'll talk about that if you are here tomorrow on service end. I'll go through the piping and show you where some of these screens are. We also have some cap tubes. We also have the linear expansion valves. And if you have black oxidation in there, you are going to plug something up, and then you're going to have all kinds of problems trying to find it. So don't want to do that. Also don't want to use soft solder. Soft solder requires you to use a flux. And on the old R22 systems, we always used to teach not to use it, but wasn't such a big deal. But now with R410 and the new refrigerant oils, that flux will actually wash off of there, and it creates little balls of gunk that don't dissolve, and they'll wash through the system, and those too will plug up the screens and various orifices throughout the system. Also, talk about the unit have to be elevated in the winter. If it is a heat pump, it's going to have to be elevated, not just on a platform, but on a stand so it drains properly and get it out of the snow and ice, because you can do damage to the equipment if it's not installed properly in cold climates, and most of our territories are at cold climates. We'll go through the 6-step installation process today as well. Okay, installing the equipment, if you're looking at walking through a home and trying to decide what to do, you want to make sure you have good sound level surfaces, structurally sound. If you're going to hang something, you can't just hang it off a sheetrock. It has to hit the studs or the floor joists or something solid, or we will have problems. Adequate spacing between them, proper airflow. So in this case, this is a big, great room, and they're suggesting maybe 2 units in there, but we have a book like this. It's available at the branches. It's called the Pocket Reference Guide, and in there it shows the airflow for all of the different systems, and also in the submittal data it lists airflow, and in the back of the latest catalog, which looks like this, which should be in all of the branches that you can pick up if you don't have this. This catalog, by the way, has both, if you can see, it has both the M and the P series equipment in it. Prior to this, we had a separate M and P catalog. M for the mini splits, P is more of the professional series that we talked a little bit about yesterday. But if you're installing this is a kitchen, for instance. You can see on the print here, these are cabinets, and this dotted line that runs across here is a soffit. So it'd be very difficult to install a head on these walls here. This is the refrigerator with the cabinets here. So your only choice here is to put one right here or right here if you're going to do a wall unit. Right here would be right by the front door, so you'd have your piping coming out and down, and if it's a 1-to-1, your condensing unit would be sitting right by the front door. Probably not the best place to put it, so probably put it over here. You got a couple of bedrooms here, maybe a guest room, maybe kids' rooms, and the master bedroom here. My personal opinion, if you're going to do a house and you bid all these rooms and all these units separately, and the people come back and say maybe it's a little more than they expected, my personal experience is if you can cool the kitchen You can cool wherever the TV is or the family gets together, and the master bedroom. You probably have a fairly happy customer. The guy that pays the bill is at least happy. The kids may be a little, it'll get some cooling down there, maybe not as comfortable as in the master bedroom, but these are all things to talk over with the homeowner. Return air circulation. These units, if they're wall units, you got to have, say, 4 inches above each of the wall unit, because the return air goes in the top. So you have to have return air to the unit. And maintenance access, if you're doing like an air handler or something, we have to be able to get to it to service it at some point. So things to consider. Also select a correct controller. If you're selling a M series unit, the M, if it starts with an M, the inside units, if it starts with the letter M, it'll come with a remote control, wireless infrared remote control. And if it isn't starting with an M, you have to add some sort of control. And even if you have a remote control, you may decide to upgrade them to a something like this control here. This is now it's called an MHK2. This one up here was the MHK1. That's in the process of going away. But if you put one of these controls on, this just plugs into the indoor board. It's just got a little interface, looks like this. It's just a little, very small little thing, easy to hide. And then your thermostat communicates to this receiver by red link. These are made for Honeywell. They're made by Honeywell for Mitsubishi, and they have red link to control between the two. The default on here would be sensing the temperature at the control, at the thermostat. So if you're mounting this thing high on a wall, maybe it's 10, 12 feet in the air, you maybe don't want to use the return air, which is what the remote controls use. You don't sense any temperature at the remote control. Remote control just turns the equipment on, you set it for a temperature, and it's sensing return air temperature. So if the unit's down in the space, or the air handler is way up in the air and the people down in the space are saying the temperature is off, you may want to install something like this, because then you get the temperature sensed right in the space. We also have the ability of using a device that's a wireless interface called Kumo Cloud, and then you can control everything through your phone app if you would want. Outdoor unit, again, these are the, when I talk about the very first slide that said, you know, that you really should look at your install manual. This is pretty typical that you need about 4 inches between the back of the unit and a wall away from the house. That will give you enough air, and 14 inches from the side and 20 inches from the front. So you don't want to plant a big bush in front of it or something. But also, I always say in the class, if you have to get behind this thing and clean the coil, can you do it in 4 inches? Maybe you want to move it a little bit further out, just because it's easier in the future. And also, they say 14 inches on this side and 20 inches on the top. Most of these units, the control board sits right up here on the top, and all serviceable parts are in this front panel and then this side right here, with the exception of the fan. Everything else is serviceable right on this end. So 14 inches, that's not very far. That's like squeezing between two 2x4s in a building. It's pretty tight. So that's the minimum. You can always go more, and I would suggest you do so for maintenance for your own self in the future. Now these wall units here come with a plate. Looks like this, kind of. It's a sheet metal type plate. It's got all kinds of holes in it. You don't have to use the holes. You can drill your own holes or make your own holes to mount, but you have to hit at least 2 studs to hold this thing on the wall. don't just screw it into, even though these units aren't very heavy, don't just screw it into sheetrock. Make sure you hit the studs to anchor this thing properly. Also take a look at the wall, make sure the wall's flat and level, because if you put this panel on the wall and you feel it rocking back and forth because it's the wall has a little bow in it, shim behind it, because otherwise the units hang on these tabs here, and if it's bowed, keep in mind it's an air conditioner and heating unit. As it heats up and cools down, it expands and contracts, and if that's bowed a little bit, you might get a little ticking sound as it heats up and cools off. Not a real big deal, but if it's above a master bed and it's 2 a.m. and they hear it making noise, you're going to get a phone call. So just make sure that thing's level. There's some tabs right here that are sticking out from the metal plate that are intended to lay a level on to level this. Because if this is level, then your drain pan under here will be level. So there's some tabs on here for that. There's a little dimple with a slot in it right here and here. That's intended to push your tape measure in and measure out however far it says. There's usually, it's printed right on here of how far out you need to go to drill your hole if you're going to run your line set directly out the back of the unit. So you measure over, in this case, 3 inches to the center of the line, and you drill your hole. And if you drill that hole, I would try to do it a little bit slightly downhill so that the condensate runs downhill. There's an opening here in the back that it was intended to run your line set through the back here if you wanted to. We have a kit for if it's a new house construction that you can put like a wall sleeve in the wall and run your line sets up to this prior to installation in new house construction if you can get behind the wall. Also right here, this is not real good pictures, but right there and right there, those are supposed to represent pictures of flare nuts. They actually are better on the pan itself. And what that is when you take this unit out of the box brand new, the line set comes out this corner and is laying underneath the pan here. It's laying back in here. What this is telling you is that's where the flare nuts are laying. If you take this line set, the small and the large flare would be laying right here. So if you wanted to bring your line set in this side and across, you could run your line set right to these marks and flare them. And then when you hang the unit on the wall, everything's going to line up. We have the ability of running the lines straight out either side, out the bottom, out the back. You know, there's other options for running the line sets here. So just be aware of that. There's a lot of information on this plate that you can use. Also, it's telling you how far here you need above the unit to the ceiling, because remember the return air goes in the top, right along here, the top of the unit. So you have to have enough room for the return air there. They're telling you a minimum of 5 1/4 inches off the side. All the serviceable parts are on this side as well. So 5 1/4 inches isn't much room. What they need 5 1/4 inches for is the return air sensor is in the side here. The air it pulls a little air through the side as well as through the top over this sensor. So they need at least 5 1/4 inches to get an accurate reading. But keep in mind, if you have to service it, can you actually fit your hands in and a screwdriver in that 5 1/4 inch space? I would always try to leave at least a foot if you can right there, just for your own ease. And again, they're showing here kind of drilling that hole kind of slightly downhill. We do sell a wall sleeve to come in here to seal this up, because you do want to definitely seal this area up, or this hole up here, for a couple of reasons. You're in the return air space, so you can suck some air and humidity in here, Remember I said the sensor is right here. That can, if that's open to the outside, that can skew that sensor. Also, there is a potential for rodents coming up the line set and coming in here. So you want to make sure this is all sealed up properly. I got a phone call coming in. Sorry about that. Okay, this unit is a concealed ducted unit. It's called an SEZ. There's also a unit called a PEAD. The SEZ is the low static. The PEAD is a little bit higher static unit. This unit right up here, I don't know if you can see, it's kind of a bluish, bluish fitting right there. That is where the condensate, there's a condensate lift mechanism in the side that spins, and centrifugal force pulls the water up and slings it out the side. So that's intended to sling water out the side, and then you can gravity feed from there. It's not really a pump as we know pumps. You can put a pump up here, have it drain into the pump and pump out from there. If this unit is hanging high enough, you can open up a little panel here in the side, unplug the condensate lift mechanism, and that little black mark there, and there's another one on this side, there is 2 drains that you can gravity drain off the bottom of this. A lot of these are sitting literally right on the roof or the ceiling, so you have to use that condensate lift mechanism. Right here is all the electronics that are serviceable parts. So if you're going to install this thing above a ceiling or between 2 floors, you have to have an access door next to it to be able to get into it and service it. If this is up in an attic, that's fine. As long as you can get to it, service it is fine. Also, I should tell you that these come upside down in the box. If you lift this out and hang it up on these brackets, make sure the brackets are on the top, the drain is on the bottom. Because I can't tell you how many calls I've had where they lift it out, hang it, and it's hanging upside down. There's a float switch in here which won't allow it to run. So on startup, if it doesn't run, you might have it upside down. I always say in the classes we teach, hands-on classes, always make sure these little fingers or tabs here in the end are always pointing down when hanging the unit, and look for those bottom drains and make sure it's hanging upright. Also mount these firmly up and make sure you hit something solid so that it doesn't pull through the ceiling. This is they call it a floor mounted unit, but it's really a low wall mounted unit. This flange here, this little metal plate, mounts on the wall, and this unit hangs on it. So typically if you have a trim board on the bottom or mop board down on the bottom, you want to be above that. Also, your sill plate in the wall is usually, you know, a 2x whatever, 2x4, 2x6 wall. So your line set comes out this bottom corner here. Typically right here, it pushes straight out, or you can move it over and come out anywhere, but the normal position is right here or this lower corner. And you want to make sure this is up high enough so when you drill through the wall, you're above that sill plate. It's dickens to try to cut through that because you only cut through half of it. So you want to make sure you're high enough, and then you don't have to worry about doing any trim work on the molding in the house as well. So this thing hangs on the wall. Suggested it hangs just, you know, 4 inches or so off the floor, but it could, because these line sets can go straight down, so you could put it straight down against the floor, and you can take the line sets down either side as it's showing here. You can go out the ends. This little mark here is so they can come out the side if you want to. But typically we drill a hole and go straight through the wall with your all your electrical, your refrigerant lines, and your condensate lines. Also, you want to be high enough that the condensate obviously runs down and again going through the wall here. So if your sill plate was right here, you'd want to make sure you're up above that. This unit is a P-series unit. It can be used on some MXZ multi-head units. This unit here mounts against the ceiling and against the wall. This part here goes up against the wall. This is up against the ceiling. Again, this cannot be hung from sheetrock. It has to go up and hit studs above it. I actually saw one of these hung with there's brackets that come out, and they didn't hold. It was actually hanging crooked and leaking on the floor. It's still running, but they needed to anchor it properly. Also in the back here, you can, on this unit, you can bring in some fresh air on this particular unit. This unit has the longest airflow throw. So this has a very, very long throw. So if you mount this up against a ceiling and a wall in a large room, you can throw the air, and unless it depends on the length of the room, but it'll throw it further than any other piece of equipment we sell. So this is intended for large rooms and kind of throwing the air over things. So now this is the SLZ ceiling cassette for recessed ceiling. This is about 10 inches, so you need about 10 inches of space above a drop ceiling. This is a 2 foot by 2 foot ceiling panel. This will fit right up in between the typical ceiling tiles. This unit hangs first, and then this plastic part snaps into place and attaches under the ceiling after you've done the install. There is two, I don't know if you can see it here. Let me see if I can, right here, kind of see there is a takeoff right here that you can do either a round or a rectangular takeoff and throw a little air out the side of this particular unit. And also on the ends here, there's a 4-inch fresh air inlet on these models as well. This is the P series. Actually, this particular one that there's an SLZ that's 2 foot by 2 foot, and then there's a P series. The P series has the takeoffs on the side, but both the M series, which is a SLZ series, and the PLA series, it looks just like this, have a fresh air inlet. This unit hangs from the ceiling, or hangs from above the ceiling, and they're in the box. There's this little cardboard piece that is intended to help you hang this. Also, the box has a template on it, so that you can literally take the little cardboard thing up on a ladder, hang all your threaded rod, because it tells you right on the cardboard where to put the threaded rod, and then this little cardboard thing tells you where the unit should hang down to before you attach this. So it makes it almost a one-man job. Lifting this up and getting it on the brackets, to me, is a two-man job, but the bulk of the work can be done by one person. Also, on this unit, there's a 4-way airflow. I don't know if you can see it in this, but there's louvers on all 4 sides of this, so you can blow air out. These are louvers here. You can blow air out on all 4 sides. But if you don't want to blow it out on all 4 sides, you can shut off up to 2. You just remove the plastic corner piece and unplug the wires from the motor, and the damper will go closed. I've had these in hallways in hotels where they didn't really want the air blowing and hitting the wall and recirculating, so they shut off the side ones and just had it blowing down the hallway on either ends. And I've also had this in an office, sitting in the center of the room, and they had a secretary in there that didn't like the air blowing on them, so they literally just shut off one of the vents, and it worked just fine. So there's some options. This is a picture of an MVZ air handler. MVZ is being phased out and being replaced by an SVZ. The only difference is the height. But I left this in here because it's a vertical upflow, downflow, horizontal left or horizontal right application. This unit was designed in Atlanta, and it's built like a truck. I mean, it's solid, heavy. It's very Similar to more of our American-made furnaces and air handlers, actually a little bit beefier, and it's totally insulated with a rubber foam inside, which makes it really solid. It's a very, very well-built piece of equipment. This has up to an inch of static on it, so this can push, you can do basically a whole home with the ductwork on this particular model. The old MVZ air handler here was 50 inches tall, and the electronics, the circuit board sat right here, and there was really nothing behind it in the top here. So they cut 10 inches off the top of this thing and made the SVZ, and they put the electronics down in front of the blower, just like we do on our typical furnaces that we're used to selling that are made in the United States. This unit is now, it was designed in the United States and it's made in Baja, California, so it's truly a North American product. The MXZ multi-zone units, some of them use a branch box. If you're going to use a branch box, it has to be mounted in certain positions, have to have a little clearance because there's electronic service board in this too, so you have to just think of that. I have seen these things mounted in closets and things, but you can usually get around it. There's two models. There's a 3-zone and a 5-zone model. It can be mounted in multiple positions, not all positions. It can be mounted on the floor. It can be hung from the ceiling. It can be mounted on the wall, left or right side on the wall, but the lines going to it have to face down. It can't be coming out the top. So you don't want this to become an oil trap. So the lines are coming in the bottom, and that's the only thing you really need to know about that. It doesn't require a drain. It does require all of the indoor heads get hooked to it. We'll go over that a little bit later here. The outdoor unit should be anchored down. As you can see, some of these are kind of narrow and tall. Some of them aren't so tall, but some of them are kind of, they almost look top heavy. And if you put this in a windy area, it literally could blow over. So you want to make sure you anchor it down. And if it's a heat pump, it doesn't get anchored that close. You have to have it elevated. Like this. This is one of the stands. We have multiple stands. This stand gets anchored down onto the pad here, and it gets anchored onto the top, so this will not blow over. We have to have plenty of space under it, that if it's a heat pump, when it goes into defrost, water literally pours off this coil and falls out of the bottom of this unit. And we want to make sure that it is away from the unit. If this thing was sitting on the ground, that water would freeze, build up, and crush the bottom coil on the unit. Also, in cold market areas, we require drain pan heaters in the bottom of the drain to facilitate that water from getting out of the unit. The drain pan heater only will work if it's below freezing and if it's in defrost. So it only works momentarily just to assist in the drainage of the water coming off of that. Mentioned this on the thing that we did yesterday, session 1. Hyperheat units, hyperheat heat pumps all come with the drain pan heater already installed. If it's a non-hyperheat unit, we need to install a drain pan heater in it. I would, in most cases, suggest you just use the hyperheat unit because it saves you the labor from putting that in. You have to take this all apart and put the drain in, the heater in the bottom here, plug it into the board. It's going to take you a little while, plus the heater itself is not that inexpensive, so it'd be better to just go ahead and get the hyperheat unit. Also, the hyperheat units will heat down to -13, so you can get a lot of heat out of these units in extremely cold weather. If you raise it off the ground but put a pad under it, you're going to get ice like this on a heat pump. So you want to make sure that it is got plenty of space under it to drain. Anchor it really well. This unit looks like it's anchored really well to some pretty solid metal, but the metal was not anchored well. So this unit did blow over. And that's never a good thing when that happens. Also, think about when we're mounting the equipment, if these are heat pumps, if this top one defrosts, all the water is going to pour down this, and this is going to be a solid piece of ice. And even if this is a cooling only unit, the serviceable parts, the electronic service board in this is right along the top of this unit, laying right on top. So I don't know, in order to service this bottom unit, you'd have to lift this top unit off. Job looks really, really nice, but not the best application. Also, prevailing winds in the winter dumped air over the top and just filled this thing all up with snow. So every time it snowed, they were out here with a shovel. So just some things to consider when installing the product. Interconnecting the wires. The one-to-one unit, one outdoor unit, one indoor unit, there is 4 wires. There's between the indoor and outdoor unit, you have S1, S2, and S3, and a ground. And from the disconnect, you have L1, L2, and a ground. So this is coming from the disconnect, and this is interconnecting between the outdoor unit right here and the indoor unit. And S1 on the outdoor has to go to S2. Sometimes electricians think L1 and L2 really doesn't make any difference, whether which one's on which wires on which leg. It does make a difference on S1 and S2. S1 has to go to S1 on the indoor, and S2 to 2, and 3 to 3, or it's not going to work. And this is one of the reasons why. The yellow wire is S1 in this case, and S2 is the blue wire. S1 and S2 together is 208, 230 volts. S2 and S3 are a DC voltage signal. It's a pulsing DC voltage. So they're using that S2 as a common for this S3 line. And if you reverse S2 and S3, the unit is not going to work. If you reverse S2 and S3 and put power on S3, you could burn out something on the board. So just be very careful. And then of course we have a grounding wire too. Some of the units are like this, color coded. Some are not. So if you're using black, white, and red wires, just remember which ones you hook them to when you go inside. Some of the guys take pictures with their cell phone just to verify so they don't forget when they get to the other end, when they're finally hooking up the inside, for instance. The control connections and all on some of these units look like this. This happens to be the MXZ, the multi-zone unit that uses a branch box. We have L1, L2, and ground here. B1 and B2 is going out to the branch box. And then down here is from the branch box, there's a connection for the controls on the branch box. These are 16 gauge shielded wires. The shield lands right there. We have another picture of this. It's a little better. Then this is the typical indoor unit we're looking at right here. It look like this. When selling these in the catalog or on the submittal data, it lists the line size. Some of the M series unit uses 14 gauge 3-wire with a ground. The ported use 14 gauge 3-wire with a ground. The non-ported, or the ones with the branch box, use 16 gauge. Some of the P series use 16 gauge. Some of the new generation P series ending in 7 uses a 14 gauge wire, and the hyperheats use 14 gauge wires. So there isn't just one standard wire. Basically, there's two different wires, a 14 and a 16 gauge. Then we also have a 16-2 that we run here, or a 16-2 with a ground or a shield here for communication on the branch box units. Voltages can vary. And again, verify this on the particular piece that you're working on, but typically it's between 187 on the low side all the way up to 253 volts on the high side. we do some things with that voltage. We'll talk about tomorrow where we clean it up and change it to DC and then back to AC and so forth. So we can take this very wide range and deal with it and be successful internally. And getting back to some of the wiring, the M series 1-to-1s, 14.3 with a ground. This is the P series system, is 16.3 with a ground. If it ends in a 7, it's a 14.3 with a ground. That M series cooling only that ends with a 7 is the P series that ends with a 7 is the ones that can cool down to -40, give you the full capacity down to -40, and that does require the 14 gauge wire. By the way, the wire on this is not as you would think that the P series would be using 14 gauge and the M series would be using 16 gauge, because M is kind of the mini split residential and P is commercial. It's really down to communication wire. They really need it for communication. The indoor units and indoor heads really don't pull much amperage. They're very, very little draw on those, but the wire is based on communication, and you want to use the right wire so you don't get communication errors. The ported type units, and by ported type, I'm talking about the indoor heads run directly to the outdoor unit. Those units are 14.3 with a ground, and the ones with a branch box, which are not ported, the ports are actually on the branch box. We run 16.3 with a ground to the branch box, and from the branch box all the way to the outdoor unit to power it, that's a 14.2 wire. And then there's also a communication wire, which is 16.2 shielded. You can power the branch box separately. Occasionally the electrician finds that easier for some reason, but if you do, you have to definitely power it up in a you power the first unit, the indoor units up first before you power up the outdoor unit. If you're wiring it all through the outdoor unit like it's showing here, when you power up the outdoor unit, the indoor units become powered and there's no communication errors. So I would always default to this unless there's some local code. MXZ C systems, these are branch boxes that were pictured here. These are indoor heads hooked to them. And these are controls, simple MA controls, which is just a 18.2 thermostat wire that runs between the control and the indoor unit. If they are a M series wall unit, starting with the letter M, they will come with a remote control, which is an infrared remote. But the indoor units wire with the 4 wires between the indoor and the branch box, and then the branch box gets powered up directly from the outdoor unit. And then we also have a communication wire that comes in here, the outdoor unit. This is showing some separate controls you probably will never use. We have the ability of having multiple systems in a large building and one master control, which is what they're showing here. Very rarely do we do that. When we get into multiple systems in a commercial building, we typically switch to Mitsubishi City multi-equipment. But it can be done. Okay, so on the MXZ control board, this is where you land your shield, because this is your communication wire, M1 and M2, and your shield. You have to land your shield here, and you have to plug in a wire that comes in the install bag and run it over to the ground so that that shield is grounded just at the outdoor unit. You say, why don't they ground that from the factory? Well, previous slide, I talked about control systems. If you are going to wire a whole bunch of these systems together and have a control panel, then you will only put the ground wire on the first unit. Everything else gets daisy chained together. Again, we don't do very many of those. I'd rather have them default to this, but parts of the world, they do put all these together. So we typically don't. Talked about splices not being permitted, grounding the S terminal. Okay. Now, if you are installing a condensate pump, this is the old way we used to do it. We still do it this way. S1 goes to S1, 2 to 2, 3 to 3, like I said. But if you have to shut the equipment off because the switch in the condensate pump's overflowing and breaks the switch, we run that switch through S1. We take S1 through the normally closed contacts on the condensate pump and run to S1 here. Like I say, there's very little amp draw on this. So this is a line voltage, but the switches in the condensate pumps can handle it no problem because there's very, very little draw on the indoor units. But if that line breaks, if S1 opens, then the equipment will shut off and you'll get an error code. That's the way we've done it for years. We still do it on most equipment. There are a couple of exceptions. On the P series, there's a CN4F connector. And some of those units I'm talking about are like the air handlers that have the float switch or the lift mechanism in them. They've got a CN in Mitsubishi language stands for connector. The connector 4F. It's got this jumper on it. And the jumper, if you cut it and wire your switch on your float switch to it from your condensate pump and break that, you'll get a condensate float error if that does open, which is a lot easier for you. Also, on some of the new Blue Diamond pumps, they're telling you to break a thermistor. So the thermistor here, there depends on the unit which thermistor it is, but CN111 is connector and RT is a resistor thermistor, number 11 in this case. They're telling you to cut the wire, but if you use the DPLS, which is a drain pan level sensor that Mitsubishi has available, it comes with this little Y adapter. You literally unplug this sensor, plug this into where the sensor used to be and plug the sensor into this. And then this end plugs into the drain pan level sensor. So it makes it real easy. You just unplug and plug everything together, and then you will get a communication error 71, which would indicate that you have a bad thermistor or this sensor is open. Mentioned it earlier that the drain has to, stuff runs downhill, as they say. You have to run this downhill. You can't run it up, or it could leak at the pan. Or if you have a long horizontal run, say in an attic someplace, and you drape the PVC or vinyl tubing, I should say, over the rafters up there, and you create little pockets where water can form, it could back up and not drain properly. Also, if you run it down into a drain, they're saying a ditch here, but a drain, you should strap it to the top of the drain and let it drip in. Don't push it down into the water, because then that also creates a trap. If you're going to run something like this on a long horizontal run, put it inside PVC or run PVC. I've seen them run PVC, and I've seen PVC run with the vinyl tubing shoved inside it just to keep it from keep it straight. So I mean, there's multiple ways of doing it, but you can't have traps. Just remember that. And you can run multiple units into one PVC pipe if it's sized accordingly. The SVZ, MVZ, that's the big air handler that kind of looks like this. This has a blower in the bottom and it pushes through the coil. So this is a positive pressure drain. The others are negative pressure. That's why we can't trap them. This one, because it's positive pressure, they suggest you trap it with this type of arrangement, similar to what we're using now on the furnaces and a lot of air conditioning coils. we do this. It's mainly trapped for efficiency, because being this is the positive side, air can literally blow out of here, and they say that's a waste energy efficiency wise, so it should be trapped. Talked about that lift mechanism in some of the equipment, the SLZs, SEZs, PEAs, PEADs. These are the air handlers that mount above the ceiling. There's little low silhouette air handlers that have a lift mechanism in it, or the ceiling cassettes have a lift mechanism in it. It will tell you in the instructions that it will lift like 19 inches or 21 inches, or, you know, what these 11/16, what that is it was Celsius converted to inches. So that's why you get these weird sizes here. Like 9/16. Why didn't they just say ½ inch? But it's when they converted to metric system, or from metric system. The this 27 inches or 19 inches is from the bottom of the unit or the top of the ceiling up. It's not from the drain up. So be very careful. If this was a 10-inch body, you probably can take 10 inches off of that. Now you can only lift it about 9 inches. So it's from the bottom of the unit up, because it literally sprays like a mist out is what it does. And you should come out with the tubing that they give you, which is a little tubing, which is fairly good size, and then reduce it from there. We talked about this earlier. Both lines need to be insulated. We sell Diamondback line sets right from Mitsubishi, or we sell some other brands that we shop for and try to get you the best price of the dual insulated line sets. Piping specifications, they don't, in the installer's guide, some of them will list a minimum. The minimum feet they recommend is 16 feet. Now, a lot of these, you mount the unit on the wall and the condensing units on the other side of the wall, just 6-8 feet away. In our training room, the longest line set I have in there is probably 6 feet long. Units are super quiet. But they're telling you this because if it's installed in a bedroom above a bed or something at 2 a.m., you might hear gurgling, or you might hear the LED opening and clicking outside, and it'll transfer through the line set, and you might hear it inside. So they're suggesting that if you put it 16 feet away, any kind of gurgling noise or liquid noises or anything like that should be eliminated by the time they get to the indoor unit. Performance will vary with the length. If you take a standard 25-foot line set, if you're under 25 foot on some of these M series units, and this is all also in the installer's guide, I'm just giving you some examples here. But in this case, if we take this 18, this GL18, if you're in here yesterday, the 18 is a nominal 18,000 BTUs capacity. Could be 17.5. You really should look at the book. It's a nominal 18. If you're under 25 feet, it would give you whatever the capacity rated is, 18. If you're out here at 100 feet, you have to use a correction factor. So we would take 18,000 BTUs times 878 if we're running 65 feet. And we'd find out that that unit there is only going to give you 15,804. So if you're going to run long distances and the sizing is critical, just make sure you do this just to make sure that you have enough capacity. It'll work fine for most of the year, but the hottest day of the year, when you're at design conditions, you're not going to make it if you run into trouble here. In the refrigerant piping, we don't ever exceed the line lengths. We stay within the recommended line lengths, even though we may have to do a calculation to see the capacity, or we may have to do a calculation to add refrigerant if we're over the recommended distances. We don't exceed the vertical separation if the unit's on the ground and we're going straight up. That's all in the submittal data or in the catalog. We don't install sight glasses because we don't have a true liquid line here. It's a saturated vapor line. It would always be full of bubbles, so there's no point in putting a sight glass in there. Also, the next guy that comes out to the job may see the bubbles in there and decide he's going to try to fill it up. We don't want to do that. We charge by weighing in the proper charge only, not by sight glasses. We don't put filter dryers in. If we have good install practices where we're using nitrogen and we're doing a proper vacuum, we don't need anything. We've got filters or little strainers within the system that will clean up any debris. We try not to have any debris, but if there is something, we'll clean that up. If it happens to be a compressor burnout or something, we may have you put a filter in temporarily until we clean up the system. Very rare do we go through compressors. So compressors, because of the way we're sensing temperatures and pressures throughout the system, so we can tell if the compressor is running hot or not and slow it down, and we will typically back it off. If the condenser's filthy, we'll not allow the system to run up to full size or full capacity. So we very rarely do we damage a compressor, but if you'd have to damage a compressor, we might have you put a filter dryer in temporarily. And we never use P-traps because that will trap the oil in the system. Again, we don't have liquid lines. So we do use a very, very good flaring tool, and we insulate both refrigerant lines. This type tool here is you put on a drill to try to make a flaring tool. That is not recommended. And the type of flaring tool that's just smooth and just a cone is not recommended. When I go out and find leaks and ask to see this flaring tool, I usually find one of these. If you have a flaring tool that's kind of dimpled like this, it kind of rolls out the flare, you probably will not have a problem. If you do a proper flare and you use a torque wrench, for sure. I always thought of a torque wrench is to make sure you're getting it tight enough. And in our case, it's so you don't over tighten it. When you're trying to tighten a little 1/4 or 3/8 flare, it's really easy to over tighten it and to get a crack in the flare. So these torque pounds can change from system to system. So you make sure you look them up in the installer's guide. We always give you the 3 different ratings. We're used to foot pounds here, but some of the torque wrenches can have these other ratings on them. We don't care. Doesn't make any difference. You just follow the guidelines here. This is, and when we're making the flare, we're using the torque wrench, but when we're making the flare, it's a good idea to put a little bit of oil on the inside, outside of the flare. I even put a little bit on the thread, so when you're tightening it up, it doesn't creak, when it's tightening. The oil you would use, ideally refrigerant oil, but most guys that I know use vacuum pump oil. They put a little bit on their finger and put it on each side of the flare. You're not pouring the oil down the tube and putting it on the surface here, and you will get a good flare. As long as you have a good flaring tool and you oil these flare fittings, you will have a good flare. Talked about this earlier. We never use soft solder, and if you are going to braze, that you use nitrogen inside of it. Speaking of nitrogen, we pressure test, or we recommend that you pressure test the system when you're done putting all the flares on to drive that pressure up to 600 pounds. You have a dual regulator, you should get it to 600 pounds. The single regulators can get up to 5, maybe 550. Probably okay, but Mitsubishi recommends 600 pounds. The internal pressure relief on the systems is set for about 700 pounds, so you're not going to do any damage. It's intended to take 600 pounds. They're telling you to put it on for 24 hours. It's not always realistic to do that. if you pressure test it at the end of the day and come back the next day, to me, that if it's still holding at 600 pounds, you're good to go. If you pressure test it to 600 pounds, go to lunch and come back an hour later, it's your call, but your meter should not change. But good practices would say 24 hours. On a little 9,000 1-to-1 idea, that's not really probably realistic to spend that kind of time on the job. Then after you do that, we relieve the nitrogen, get it down to 0, and we hook up a vacuum pump and pull a vacuum. And the way that is actually a faster way to pull a vacuum is you evacuate down to 4,000 microns, and then you break that vacuum with a little bit of nitrogen. So you have to have kind of a neat little setup to be able to pull the vacuum and break it with nitrogen down to get it down to 0, and then you pull it down to 1,500 microns, break it with nitrogen, and then go down to 500 microns. Doing this will actually typically be faster than just putting the vacuum pump on and letting it go to get it down to 500 microns. Again, on a 1-to-1, a 9 or 12,000, this isn't going to take you long at all, especially if you've got less than 16 feet of line. On a MXZ with 8 heads on it, it'll take a little bit longer, but it's still faster to break it with nitrogen. The nitrogen is a dry, inert gas that has the ability of actually absorbing a little moisture in the system. So if you're pulling a vacuum and you take it down to 500 microns, let it sit there for 60 minutes. If that gauge doesn't move, you're good to go. If it rises or goes from the 500 microns closer to 0, in other words, loses the vacuum, you either have a leak or there's moisture in the system that's boiling off. If you're doing the nitrogen in between the pull downs, chances of moisture, unless there's a lot of moisture because of some other reason, is very minimal. So typically, if there's a leak, you'll find it when you're charging to 600 pounds of nitrogen. If this raises, then you might be boiling off some moisture. Okay, then we charge and test the equipment. If we're going to charge this system, we're going to typically on these M series up to 25 feet, you don't have to add any charge, and most of the time you're, like I say, you're under 16 feet, so we're not adding charge to most of our systems. But if you have to, if you exceed the rated charge, you look in the installer's guide and it'll tell you, in this case on this MUZ, to add, once you go over the 25 feet, in this case, if you exceed 25 feet, you add 1.8 ounces for each 5 feet after that. And again, this information may vary, but it'll be in the installer's guide. The P series you'll see is a professional series. Those are typically okay to 70 feet. Some of them go all the way out here to 100 feet before you have to add any charge. And some of these may only go up to 95 feet total in the M series. The P series, you can see some of them go down to 165 feet. So you can run the P series a lot further, and you just add the appropriate charge for that. Now, the MXZ multi-zone unit with a branch box, that unit will always add additional charge, even if you're running very, very short little line sets. In our training room, the longest line, I've got like 5 zones on an MXZ. The longest line set I have is probably 10 feet, and that's from the outdoor unit to the branch box. From the branch box to the different heads, it's like one of them's less than 2 feet. Some of them are 6 feet, and I still had to add refrigerant. So any time there's a branch box, the only refrigerant that's in the unit is for the outdoor unit. You have to figure your lines and what type of heads you have to determine how many ounces or pounds of refrigerant you will add. You can do it by this method, by adding all this up, and we'll do a quick little way of doing this. This is the MXZ 8C48. It's a 4-ton unit, and we're putting 98 feet of pipe between the outdoor unit and the branch box. What you have to do is add up all your liquid lines, how many feet a 1/4 inch you have, how many feet a 3/8 you have, and you have to add up the BTU capacity of the indoor units to find out, you know, what your BTU capacity is. So an example of that would be, we're going, I think it was 99 feet from the branch box to the outdoor unit. We're using 3/8. And then on the 2-ton unit, we're running another 49 feet from the branch box in 3/8. So we have to add 99 and 49 together. And then on the 15,000 BTUs and the 2 9s, those are all 1/4 inch. We add up all this pipe here. So we've got 131 feet of 1/4 inch pipe, 148 3/8 pipe. And if we add up 24, 15, 9, and 9 for the BTU capacities, it comes up to 57,000 BTUs. So we got 57,000 BTUs of connected heads on a 4-ton unit. That is acceptable. You will not get 57,000 BTUs of cooling out of a 48,000 BTU piece of equipment. You're only going to get about 48,000 BTUs or less out of this combination. But you can mix it up like this and it's totally acceptable. It's about 30% over capacity you can do on most of the equipment. So what we did is we added up the 3/8, the 99 feet and the 49 feet. We came up with 148 feet, and of the 1/4 inch, we added the 33, and the 66, and we came up with 131. When we added all this together, we came up with 57,000 BTUs. We take all of that and we take the 131 times the 0.21 and 148 times the 0.55 that's listed in the installer's guide. We come up with 27.51 ounces of gas for the 1/4 inch lines, 81.4 ounces for the 3/8 lines, and the connected capacity here, we were at 57, I think. We came up with 106 ounces. We add those together, we get 214.91 ounces. Typically, we'd round up probably to 215. At 16 ounces a pound, you divide 215 by 16 ounces, you come up with 13.4 pounds additional that you would have to add to this system. Kind of nice to know, excuse me, kind of nice to know going into the install or while you're bidding the job to sell, that it's going to take 13, almost 14 ounces of, or 14 pounds of refrigerant. Another way of doing it is there's a Diamond System Builder that's on mylinkdrive.com under software. It's a free download. It doesn't cost you anything. You have to register it, but it doesn't cost you anything. Literally, when you bring it up, you have to pick your area so that you have your design conditions. You pick your area, and then you click on outdoor unit. You pick on the model number that you are installing, in this case an MXZ 8C, and it sits it out here on a thing. It looks like a blank piece of paper, and you grab the branch box and you drag it across, and then you grab the wall units or whatever the indoor piece of equipment is and put it in here, and you pick the BTU capacity, put in the feet of pipe, and it will determine how many BTUs out of each one of these pieces of equipment and total BTU capacity you will get under the design conditions for your area. This happened to be for Minneapolis that I did. And then down here, it tells you the 14 or 13.4 pounds of refrigerant, the same thing we established when we did the math. I work with David Philibert here. He always does it longhand, does the math. I always use the software here because I don't trust my own math. But we always come up with the same figure. It always comes out exactly the same. So it's kind of nice, easy system to use. Okay, quickly we'll talk a little bit about jumpers and dip switches. The jumpers you probably won't see too often. There's only one time I've had to cut a jumper, and that is on some of the equipment. In the old days, if you wanted to shut the blower off, because the blowers run all the time if you use a handheld remotes, and if somebody complains in the winter that it's blowing cold air, it's very slow, very low velocity. But if somebody complains, you can cut one jumper and shut that equipment off in heat mode, and there's a different jumper to cut in cool mode, that sort of thing. I never liked cutting jumpers. So most of the new equipment, they do all this with dip switches, or you do it through the thermostatic control system. But on the system, there's also dip switches that are for addressing the equipment. If you do multiple pieces of equipment, auto restart, preheat control, defrost, finish temperature. Typically in our markets, we don't have to do any of this. We do have an area up off of south of Lake Superior up there that has some lake effect snow and high humidity conditions that they change the dip switches to run a longer defrost and a higher temperature defrost to make sure that the ice and snow comes off the equipment. P-series, you can use a dip switch to throw it in a test run. The M-series, we put it in test run by pushing on the wall units. There's a test run button on the inside. And you can force a defrost. So if you run into a unit that's all frosted up for some reason and you want to get it defrosted, you can open it up and get into the dip switches and force it into defrost. You can also do a pump down. There's a number of things you can do with this equipment. So that's MXZ 8C. We'll talk a little bit about that. There's a bunch of dip switches on there. There's also these rotary switches here for addressing an address of the outdoor unit. There's also rotary switches on the branch box. You can do, like I say, by adjusting, depending upon which switches you switch, it'll do different things. We'll talk about SW1 in a little bit. That's a display. SW2, you can do things like pump down. These SW2-5 through 6 are model selection. We can use the same board, electronic outdoor board, in multiple equipment. It may be a 42,000 or a 4-ton or a 5-ton unit. And we would have to adjust the dip switches. If you ever had to change your board, you just copy whatever the old board is, make sure the dip switches on the new board are the same. We are running out of time here, but I'll keep plugging along. On the branch box, there is a set of rotary switches that have to be addressed, and on the outdoor unit you have to address. You see on the bottom here, it says anything between 51 and 100 or between 1 and 50. And then on the branch box, there's also, these are the ports you're using. So if you put a 5-zone branch box in and you're only going to use 3 ports, you only switch the 3 switches that you're using, or the 3 ports you're using. Now, you can address the outside unit as 51, and the indoor units, it says to go like 01 for the first branch box. It sometimes gets confusing because if you'll notice, this is switch U1, this is switch U2. You put a 5 here, or 1 here, or 1 here, or 5 here. So sometimes we tell people to address the outdoor unit as 55 and put the branch box as 11. Then it's a lot easier to set the addresses. And if you have 2 branch boxes, put the second branch box at 22. Makes it pretty easy. You can call up and ask us. This is the way they tell you to do it. Set it at 51 on the outdoor unit. and O1 on the branch box, the branch box automatically will address the attached equipment. You don't have to do this. So if you address this as O1, the first unit would be a 1, 2, 3, and if you have a second branch box, you address this as 4, and then this would become 4 and 5. Nobody ever sees this. You'd never know what the addresses were. So, you know, our way of doing it a lot of times is put 55 here, 11 here, and 22 here, and nobody would see what these addresses are down here. It'll work just fine. System startup. Want to make sure you check all your refrigeration work, trim charge if you have any. If there's an address that you're putting on the equipment, make sure that's correct. If you've changed any dip switch settings, you may want to also write all these things down. I'll show you a piece of paper you can write these on that's free that you can download. Just system inspection so that it maintains efficiency. You can always point to this as in the warranty statement that it's recommended that this be done on a normal basis, that it could void the system warranty if it wasn't performed. I've never voided a warranty for this, but it is something if you're selling service agreements that you could point to. Collecting startup data is not a requirement, but this is these pages that I'm going to show you here are on MyLink Drive here that you can download. It's all the data about the address and the homeowner's name, pressure tests that you took on day 1. Day 2 has got a lot of also some different voltages and different things that you can write down to keep for your records. And page 3 is the indoor units. If you have multiple indoor units, you just print this a couple of times and write down all the data. It's nice to keep in a file. So if 5-10 years down the road, if the homeowner calls you and says something's wrong, you can see what all of the voltages and pressures were on day 1, and it's worked for 10 years. Let's make sure it's still performing the same. The warranties, the typical warranty, if it's not registered, if it's just installed and nobody ever registers it, you get 5 years parts, 7 years compressor warranty. And if nobody says anything, that starts from the day they ship the equipment to us. If you can prove when you installed it or when you bought it from us, we can extend that to the 5 and 7 years. But when you install it, if you go online and register it, you would get 10 years parts and compressor warranty. If it was installed in a single family home, not a rental property. But it must be registered within 90 days. And if you're a diamond contractor, which means you go through a class similar to this, but it's a 2-day class and there's some hands-on training and so forth. You have to go through that and you have to agree, there's certain sales requirements of how much you're going to buy and sell and code of conduct that you have to sign. If you become a diamond contractor, then you would have 12 years parts and compressor warranty. There is no labor warranty on any of this equipment. It's all parts warranty. There is an extended warranty that we can sell that does cover labor to the consumer. So that is available. P-Series basically is the same warranty. It's 10 years parts and compressors warranty on commercial installations. And that is if it's registered within 90 days. Diamond contractors would get the 12 years, but it must be in a single family home. And again, this is a professional series. Sometimes it goes in a single family home, but not normally. Okay, let's talk a little bit about the controls here. Like I said, all the M series units that start with the letter M come with a remote control that looks something like one of these, depending upon what model indoor unit you purchase. If it doesn't start with an M, starts with an S or a P or anything else, then you would have to include a wired stat, which is an accessory, doesn't come with it. You'd have to bid that. And we have several options there. And then we have these wireless controls which are what we sell the most of. And those will work with any of the systems we have, from the M series that come with a remote control. You can still use this on it, or the P series, or any device we sell, even through the commercial products that we sell. These controls work with that as well. Through those controls, like I just mentioned, the wireless controls that were on the right-hand side of the page, they come, as soon as you hook them up, they default. They go through 28 things, and it knows right away the model it's hooked to and everything, and it does some default setting immediately. So it knows if it was an SVZ, and it knows if there's 1 louver, 2 louvers, 4 louvers. It does all the adjusting, so there's nothing for you to do on that, but you can. There's a bunch of other things that you can set, like if you want to. Its default is Fahrenheit, but if they want Celsius, you can change it. You can change auto changeover. If it's an MXZ, I would suggest that you remove the auto changeover and make it a manual changeover, because the MXZs, the multi-headed units, you can't have one heat and one cool at the same time. So I usually make it manual. The default is that the temperature is sensed at the control, and that's usually fine. That's perfect. But if you wanted to, you could change the source and sense it at the indoor unit, the return air sensor, if you wanted to. Number of things you can change. So also you can get, if it's one of the air handlers, you can change the static pressure setting from these controls as well. One of the controls we touched on briefly was a Kumo Cloud. That's the Wi-Fi device. This little device plugs into this connector 105, CN105, and then you have access over your cell phones or smart devices or computers. And they literally talk to the router. You have to have a wireless router to make this work. You set it up through your cell phone, through Bluetooth, and then you hand it off to the homeowner by emailing it to them. And then once they sign into it, you no longer have control of their system. They have total control. There's a couple other controls. There's several controls. I'll talk about these briefly. This is a device that lets you put it on BACnet, a commercial control system, if you wanted to. That also uses the CN105 connector. There's only one CN105 connector per device, so you can only do one device plugged into that. So any one of these controls, but you can't have different controls on it. The exception to that is the MHK2, which is that red link control. That has two plugins, the CN105, so that you can hook the Kumo Cloud to that. So you can have the wall thermostat plus have it be Wi-Fi if you wanted to. This is a control system, a commercial control system. This is something I'm not real keen about, but I'll mention it. It plugs into the CN105. This is a conventional thermostat interface. So if you have a homeowner that's absolutely in love with their thermostat, Nest thermostat or something, you could hook something like that to this device. Inside here are some dip switches that have to be set up. You also have to have 24 volts to this, which makes this in some cases difficult. If it's a wall unit, there's no place to mount this, no place to mount the transformer. If you can find a place to mount it, it will work, and it requires a 2-stage thermostat, 2-stage heat, 2-stage cool, conventional thermostat, not a heat pump thermostat. So there are some options there. On the inside unit, there is an emergency switch and a test run switch that you can put the unit in emergency test run. It'll stay there for 30 minutes. Just so you know, if you put it into this mode, it sets the temperature for 75 degrees heat, 75 degrees cooling while it's in this mode. It'll stay in this mode. If you hit it once, it's in the cooling mode. You hit it twice, it's in the heating mode. Hit it 3 times, and it's out. So if you have a customer that loses their remote control sometimes in the summer and they call you, it's hot in there and they can't get the unit going, you just push the emergency operation switch, test switch once, it'll give them 75 degrees of cooling. So just something to be aware of. And occasionally you'll have somebody ask, there's some lights on here that come on and sometimes blink. If they're both on, it means that it's more than 4 degrees off a set point. So it's just come on and it's starting to cool. As it gets closer to set point, one of the lights will go out. That means it's between 2 and 4 degrees off a set point. And if the light's on all by itself, it's in standby mode. Also, that's the same light we'll talk about tomorrow when it comes to service. If you get a flash code on there, a blinking flash code, it will tell you, it could steer you in the right direction to find out what's wrong with the system if there is a problem. So that's it. 4:31, that's not bad. We did okay. 4:30, so we've been doing this for an hour and a half. I apologize, it's a long session. Tomorrow we're going to talk about how to troubleshoot the system. We're going to do a functional overview, go through the wiring diagrams, go through how the equipment actually functions and works, what the design is, how it works to help you in your troubleshooting process, and then we'll go through some troubleshooting techniques as well. So that's it for today. If you've got any questions, you can unmute your mic and ask a question. Otherwise, we can call it a day. Thank you very much. No questions? Okay, thanks, guys.